Assalamu alaikum everyone. This is paper 4, May-June 2025. It's all about 80 marks, 6 questions. I'll show you exactly what the examiner wants for each mark. Just grab a pen, pause before each answer, and try it yourself first. Question 1 gives a list of substances. Each substance can be used once, more than once, or not at all. It's pure recall. Let's see part A. Basic oxide. Actually, when they ask about basic oxide, they need metal oxides. So which of the following is a metal oxide? It's calcium oxide. So A is gonna be calcium oxide. Part B contains carbon atoms only. You know the carbon comes in two different forms, diamond or graphite. One of them is here, which is graphite. Is manufactured by fermentation. Fermentation of sugars makes ethanol. It's produced by decomposition of vegetation. Rotten vegetation gives off methane. It's a biogas. Contains aluminium oxide, which is a bauxite. It's ore. Causes acid rain. Sulfur dioxide dissolves in rain and makes acid rain. A simple molecule with 11 atoms. Actually, here they ask sometimes about hydrocarbons, and here you have two hydrocarbons, which is propane and the propene. Write the general equation for each. 1CnH2n plus 2 for alkane. Then apply 3 propane. It has 3 carbon atoms, so 3 carbon atoms. So we're gonna say 2 times 3 plus 2. You will have here 8. So 8 plus 3, 3 plus 8 equals 11. So here the answer for this question is gonna be propane. It is produced when limestone, which is CaCO3, decomposes in the blast furnace. It gives two products, calcium oxide, and it gives carbon dioxide. So the answer here, check the answer, it's gonna be calcium oxide. Calcium oxide. So we used calcium oxide twice. It's a gas that approximately 20% of clean dry air. We know the air that's 78% of nitrogen and 21% of oxygen. So here the answer is oxygen. It's a monomer in addition polymerization. Addition, which means we're talking about double bond, and the propane has double bond, so the propane, it's the monomer. Question 2 is about the atomic structure, the protons, neutrons, and electrons. Here you have 2 marks for the charge column, 1 mark, and the relative mass, 1 mark. As you know that the charge of the electron is -1 and the charge of the proton is +1, here the mass for the neutron equals 1 and the proton also equals 1. Part B is about the isotopes. Let's see, we have 2 isotopes of potassium. Since they are isotopes, so the number of protons are the same for both. And the first one is neutral, so the number of electrons is equal to the number of protons. And then we can minus 39 minus 19 to get the number of neutrons, which is 20. For the second one, it's an ion, which means it loses 1 electron, so it's gonna be 18. And here it's number of neutrons, 41 minus 19 equals 22. So here 22. Part 2, it's about calculating the relative atomic mass of the sample of potassium to 1 decimal place. Here we can multiply each mass by its abundance, then add them, divide by 100. For example, the first one, 39 times 90 plus 41 times 10 over 100 is gonna be 39.2. So the answer is 39.2. Part 3, an isotope of aluminium has a nucleon number of 27 and the relative atomic mass also 27. So the nucleon number and the relative atomic mass are the same, which means it has 1 isotope. So we're gonna say aluminium has only 1 isotope and has a nucleon number of 27. Third part, an isotope of aluminium has a nucleon number of 27 and the relative atomic mass also is 27. In this case, the nucleon number and the relative atomic mass are equal, which means the aluminum has only one isotope. So aluminium has only one isotope, which has a nucleon number of 27. C. A calcium atom has electronic configuration of 2882. Give the formula of one atom and one negative ion that the same electronic configuration as Ca2 positive, which means this electronic configuration will be 288 because calcium in this case it loses 2 electrons. The atom is easy because it's the nearest noble gas, which is argon. For the negative ion, for example, the chlorine is 17, which is 287, and when it gains 1 electron, it becomes Cl negative 288, which is the same electronic configuration. Question 3 is about copper and copper compounds, and here he asks you to describe the bonding in the metallic elements such as copper. The metallic bonding, it's actually the attraction between the positive ion or cations and the delocalized electrons. But here we have 3 marks. 1 mark to say that the attraction, it's the attraction between positive ions and delocalized electrons. Explain how copper conducts electricity. The delocalized electrons, they are free to move and carry the charge. Copper is in alloys such as brass. State one reason why alloys are more useful: because they become harder and stronger. So they are harder and stronger. Name the substance that is present in the brass other than copper. Brass is a mixture of copper and zinc, so the other substance is zinc. C. Copper sulfate crystals are made by reaction between copper carbonate and dilute sulfuric acid. The sulfuric acid has concentration of 0.100 mole per decimeter cube. Read the steps. Question 1. Give 2 observations in step number 1. In step number 1, powdered copper carbonate, which is solid, it reacts with dilute sulfuric acid. So the first observation, solid disappears, or we can say copper carbonate disappears. So solid disappears. And the second observation, carbonate, it means the carbon dioxide is formed, which bubbles, so we can say here also bubbling. Question 2. State why reaction stops in step number 2. In step number 2, more copper carbonate, so the excess here is copper carbonate, and the reaction stops because the dilute sulfuric acid is used up. So the answer will be all sulfuric acid. All sulfuric acid has been used up. Number 3, name the residue in step number 3. Here, step number 3, we remove the unreacted copper carbonate by filtration. So the answer here, copper carbonate. Name a substance other than copper carbonate that can add it to dilute sulfuric acid to produce aqueous copper sulfate. You can say copper oxide or copper hydroxide. Copper oxide or copper hydroxide, but you cannot say copper only because it's below the hydrogen in the reactivity series. 5. The solution at the end of step 4 contains the maximum amount of copper sulfate that will dissolve at that temperature. So the maximum amount of solute in a certain solvent at certain temperature, this is the saturated solution. Saturated solution. Step 1 is repeated using sulfuric acid of concentration 0.200 mole per decimeter cube instead of the first concentration. So it means the concentration here increases. So what happens to the rate of reaction? The rate of reaction increases. Explain why rate of reaction increases. Give your answer in the terms of particles. So more acid particles per unit volume, it makes more collision per unit time. So it increases the collision frequency. So we can say that in the answer. Number 7. Copper sulfate has this formula. State the term used to describe substance that is chemically combined with water. So if you have any substance that is chemically combined with water, we call this hydrated.